Welcome! In today's tutorial, we'll be giving you a quick introduction to using local SSDs in your Google Kubernetes Engine clusters. Let's get started in this fresh project, and first we'll enable the Kubernetes API. Then we're going to create a Kubernetes cluster that's optimized for local SSDs and demonstrate the simplest way to use them. As soon as the service is enabled, let's go to the clusters page. This is where we'll construct our standard cluster. Remember, this choice is critical because autopilot clusters do not support local SSDs. Let's then opt for a standard cluster configuration and subtly adjust the default node pool configuration. Thinking ahead, maybe 2 separate nodes are necessary. 3 is typically recommended for high availability, but we want to keep things simple for a more straightforward hands-on review of some key concepts. For our node configuration, the defaults are likely good enough, but keep in mind your hourly cost and also note that the local SSD configuration is an add-on to our standard boot disks, offering you fast but pod lifecycle constrained storage. Spot the little question mark next to the node locations and machine configurations? Let's click on it. This tells us that every node in our cluster gets its own SSD. However, note that this is not supported for the existing CPU type, so we need to switch this over to a different CPU architecture. For example, we could do N2 and set a single local SSD disk. Want to see the cost implications? Let's show the cost breakdown. The additional cost is about $60 for 2 nodes, or roughly $30 a piece for these local SSDs. In terms of capacity, we're looking at around 375 gigabytes per local SSD, so that's a total of around 750 gigabytes of locally attached SSD storage across the whole cluster. That's probably okay for our demonstration here, so let's click Create. Once that cluster is all set, we can click into it and check out the nodes. Remember we created a 2-node pool? Clicking in, we can see some of the details of this particular node. Now, with standard GKE node clusters like this, we can actually go to the specific VM instance backing the node and SSH into it. Checking this out can be instructive as far as seeing how this local SSD works. We'll invoke standard Linux commands here to reveal the disks we have. The disk of interest is this 375 gigabit NVMe disk, which is our local disk that we've mounted here to handle ephemeral storage. Let's head over to our Cloud Shell to provision a pod and see what this experience looks like from the native Kubernetes perspective. First, we'll need to authenticate with the cluster. In this pod specification, we have a volume that's going to be the empty dir type, so this is going to use ephemeral storage. We're going to be mounting that as an Nginx cache just as a simple example. Let's see if that kubectl apply worked for us. And it does look like we have a running Nginx pod. No, on this Nginx pod, we see our ephemeral storage being used for our cache directory, as well as some DNS stuff. We could create a number of pods and they'd all use that kind of local volume on the node. Keep in mind that this has to be an ephemeral volume type because these local SSDs are attached to their specific nodes, So if the pod moved between nodes, this directory would be recreated. Using this for something like a cache could be potentially quite reasonable. We can also check out the node configuration with the describe command, and we'll see things like the ephemeral storage. Looking at this, we have 385 gigabytes of total ephemeral storage. Not all of that is allocatable, but we have quite a lot available. Now, all this is kind of the standard way to handle these local SSDs with the ephemeral storage. There are other more advanced models. If we go to the Add Node page and check out the node configuration, we can see the other option for local SSDs, which is in Advanced. Specifically, we can set this up as raw block local SSDs, in which case we'd be using the host path volume types or local persistent volumes. Again, these are going to be attached to our node though, and typically for ease of use, you'll want to use more of an ephemeral storage type model. We hope that this video was helpful and want to thank you very much for watching. Please enjoy responsibly.